Hi friends, today I'm going to show how to make a variable DC power supply. A commonly used IC, this LM317 is a commonly used IC, and see the input can be from 3 volt to 40 volt. The input can be 3 volt to 40 volt, and we can get output 1.25 volt to 37 volts. 1.25 to 37 volt. Now, if you want output to be 0, then you can add these two diodes. Adding two diodes, you can bring this voltage to 0. Then I think it will vary only 0 to 33 volts. So you can just roughly we can say it varies from 0 to 33 volt. Okay, now the circuit. If you see the circuit, the first pin is the adjust pin, and the second is the output, and third is the input. From the output, we are having a voltage divider network. So the first resistor connected to the second pin is the R1, and the next one is the R2 10K. Now there is a now we have an equation to find the output. This V out is given by 1.25 multiplied by 1 plus R2 by R1 plus 50 microamps multiplied by R2. But this is the current flows through the adjust pin, the first pin, that is the adjust pin, the first pin. This 50 microamps to 100 microamps typically flows through the first pin. Okay, so this part is the value is very small, so this can be neglected. And now, so we'll end up with the remaining part, that is 1.25 multiplied by 1 plus R2 by R1. Now in this is a variable power supply. For as a hobbyist, anybody can make this circuit and use it. It's a very simple circuit. We can make it at home and use it. So this R2 is the variable resistor. By varying this pot, we can vary the voltage from 1.25 to 37 volt, depending upon the input voltage. If you have a 12 volt, then below 9 volt, you can get at least your output, whatever the output voltage you want, the input has to be 3 volts greater than the output voltage. Okay. Now sometimes we need a fixed voltage regulator. Assume that we need a 5 volt. Then what you do, you'll choose, you will try to fix, normally you'll try to fix this R1. Now I want 5 volt. If I want 5 volt, what are the values I can choose? I will choose this R1, I will choose it as R1 equal to 200 ohm. So R2 I can choose 600 ohms. Okay, now R2 by R1, that is 600 by now our equation is 1.25 multiplied by 1 plus R2 by R1, 600 divided by 200. Now if I do this, I'll get 600 by 200, 3 plus 1, 4 into 1.25, 5 volt. See, this is very simple to calculate. Okay, and I have tested this circuit. It can provide up to 1.5 amps, but this LM317 has to be connected with a heatsink. It has to be fixed with a heatsink for the heat dissipation. And this capacitor on the input side capacitor, this is the see, just to, if your power supply is your power supply filter, If that is away from this input, you need this filter to bypass some noise. And the output capacitor C2. This is for the output transient response. Steady state, it doesn't matter if this circuit is there or not, but for the good transient response, this capacitor is must. And see, normally the values used are C2, that is the C2, that's the output side capacitor, that is 10 microfarad, 50 volt. And the input side, that is 0.1 microfarad, 50 volt. So what we will do, we will construct the circuit and test, and so we will see. I don't have a higher power supply to supply 40 volt, so I have a laptop charger which has an output of nearly 20 volt. So we'll try to rig up this circuit and test it out. Okay, let's start.